All right, let's look at the homework 15.3, problem number 8. All right, so let's evaluate this double integral by reversing the order of integration. All right, so let's do that. All right, so first I'm going to try to sketch the region. So here's the x-axis, and here's the y-axis. All right, and let's see. So doing with respect to x, so the equation is x equals arcsine of y. We can easily turn it into, since I don't like arcsine here, so I'm going to apply sine to both sides. Then you can see that it's actually just a sine of x is equal to y. Right? So we can sketch the picture fairly easily because this is just a sine curve. So I'm going to put pi over 2 here. Then sine is going to start from the origin, and it's going to probably hit 1, value 1 at pi over 2. So you have that, and here this value there is 1. All right. Then let's see, the top end is x equals pi over 2. It's actually, so x equals pi over 2 is this straight line here, a vertical line. So between those two guys, and y is going from 0 to 1. So we know that the region we are looking at integrating over is this shaded region right here. All right. So we can reverse the order of integration. So we have double integral, right? Then the integrand is going to stay the same. Square root of 16 plus cosine squared of x. So we're going to do it with respect to y now, all right? All right, so if you want to do y first, you can see that the bottom curve is just a x-axis, which whose equation is y equals 0. And the top curve here is y equals sine of x. So we can see that this integral goes from y equals 0 to y equals sine of x, all right? Then x value goes from 0 to pi over 2. So that's an easy one to tell. So 0 to pi over 2. All right, so let's evaluate this integral. All right. All right, so what we want to do is I'm going to use the substitution here. All right, actually, before we do the substitution, since this is with respect to y, so these guys have nothing to do with y. So it's actually a constant. So I'm going to actually pull those guys out of the inside integral. So you have a cosine of x, square root of 16 plus cosine squared of x. Then we have an integral from 0 to sine of x, and there's nothing left, so it's going to be 1 dy dx, right? And then this part is really simple to evaluate, so I'm going to go ahead and do it. So this integral of 1 is y, right? Then you're going from 0 to sine over x, sine of x. So plug in sine of x, so you have a sine of x minus 0. So I'm not going to write that. So that's just going to be sine of x, right? So what you get is going to be, so you have an integral from 0 to pi over 2, right? So you're going to have a sine of x from that integral. Then you have cosine of x, square root of 16 plus cosine squared of x, and with respect to x, right? Then here I'm going to use a substitution. I'm going to let u be inside the expression inside the square root. So 16 plus cosine squared of x, right? So this is going to be our substitution u, right? Then as usual, I'm going to just go ahead and take the derivative. So you have a du over dx is equal to, all right, derivative of 16 is 0. Derivative of cosine squared would be 2 cosine of x times derivative of cosine is negative sine of x, right? So if you solve for, let's see, dx, I'm going to just take the reciprocal. Dx over du is equal to 1 over negative 2 cosine of x sine of x. Then we can just multiply through by du, right? So dx is equal to du over negative 2 cosine of x sine of x, right? So we do that. So you have an integral, right? So I'm going to leave sine of x and the cosine of x as it is. Then this is going to be a square root of u, right? Dx is equivalent to du over negative 2 cosine of x sine of x, right? And I have to do a lower bound and an upper bound. So originally, x is going from 0 to pi over 2, right? Then this means that the u is going to go from, if I plug in 0, cosine of 0 is 1, so it's 17, 2, and pi over 2, cosine of pi over 2 is 0, so it's a 16 plus 0, so it's 16. Right, so we're going from 17 to 16. Right, so one thing you can do is we can use this negative sign, so turn it into positive. Then we can switch the lower bound and upper bound. So this is going to be 16 to 17, right? And also we can cancel sine of x on top and the sine of x on the bottom, cosine of x on top and the cosine of x on the bottom. So what you get is going to be, let's see, 1 over 2 is just a number. So I'm going to put it out here. The integral from 16 to 17, right? Square root of u can be rewritten as u to the 1/2 power. Then you have a du, right? Then we can just take the antiderivative. So antiderivative u to the 1/2 power is add 1, so u to the 3/2 power. Divide by 3/2 is equivalent to multiply by 2/3. Then you're going from 16 to 17, right? So we can cancel 2 on top and 2 on the bottom. So we have 1/3 is just in front. Then we're going to have 17 to the 3/2 power minus 16 to the 3/2 power, right? So we have that. So what's this? So we're going to have, right, this is going to be, actually, this is 1/3. Right, 1/3, 17, the 3/2 power would be 17 times square root of 16. Actually, 17 I meant. Minus, this is same thing as 16 times square root of 16. But the square root of 16 is 4, right? So we end up getting, can't really do much with the first guy, so it's 17 square root of 17 minus 4 times 16, so 64, right? So let's type it in. All right, so we got 1/3, then we have a 17 square root of 17 minus 64, right? Let's check the answer. Submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.